I2, F2. So we know it's going to be nickel something. Nickel something. We don't know what it is. Fluoride. Okay. Right. So, how do we figure out what this something must be? Well, we know that fluorine is going to be taking one, takes one, and we don't know how much nickel is going to be taking. Okay, but we have these right here. So, if we do reverse crisscross is a strange way of thinking about this. That means that overall, there's going to be a taking of two. This is going to be taking two electrons. And this is going to have to be giving two. Okay. I actually haven't explained this in any way like this before. So I hope this is making sense. Okay. So nickel is giving two and fluorine is taking two. Okay. There are two of these nickel atoms here and there are two of these fluorine atoms here. Overall, all the fluorines are taking two, and overall, all the nickels are giving two. Okay? So think about that. Overall, these nickels are giving two, and overall, these fluorines are taking two. But we know that fluorine normally only takes one electron. Okay? Okay. And here, if overall you're giving two, and there are two nickel two nickel atoms, so there's two nickel atoms here. That must mean that each of the nickels are giving giving one electron, because overall they're giving two, and here they're two fluorine, and overall they're taking two, so that each one of them takes one. So each one of them is taking one here, and each one of these are giving one. So the final answer must be nickel 1 fluoride. Okay. I hope that made sense. Let's go the reverse. Let's go from the name to the formula. Let's do this. Let's say that we've got... Let's do niobium, which is right here, element number 41. Niobium, Nb, and let's do a tricky one. Niobium 3 oxide. Let's do niobium 3 oxide. Okay, what's the formula here? We know it's going to be Nb something, O something. We don't know what those are going to be yet. Right, let's see if we can do this. We'll set up with Nb and then O over here, and we'll figure it out. Okay, we know that oxygen normally takes 2 electrons, and we don't know how many niobium is going to be giving. But we do know how much it's going to be giving. Why do we know that? This 3, you're such a sweet little 3 right there. It's going to be giving 3. So this is much easier going from the name to the formula. So the niobium 3 now is going to be giving 3 electrons. So we can crisscross applesauce. I'm so happy. Crisscross applesauce. This is going to be a 3. That's going to be a 2. So it's going to be Mb2O3. Yay! It works just like a regular ionic bond problem. The difficulty is when we're going from the formula back to the name. So let's do that same problem, but now let's pretend we don't know this name, and let's go from the formula back to that name. Okay, so let's pretend that we're just given this Nb2O3, and we don't know this. Let's just pretend we don't know that. Okay, so I'll start over here. Nb2O3. We know that normally oxygen takes 2. We don't know how much, because we don't know what this name is yet. We don't know how much it's going to be taking. How can we figure this one out? Well, let's try a reverse crisscross applesauce. this would be giving 3. This would be takes 2. Right. We didn't actually need to write takes 2 at the beginning of that. So I'll just erase that. I think that's where I might have been mistaken before. Okay. So this is giving 3 and this is taking 2. That seems in line with oxygen normally. And this is, well, it's a transition metal, so we don't really know how much it's normally going to give. So we can rewrite this as niobium, and since it's giving 3, we can do that from reverse crisscross applesauce, and we can write the oxide at the end. Okay, so that should be an easier way of thinking about this. Right. So the tricky part right here is because we didn't know how much in this nickel 1 fluoride right here. It was a 2 and it was a 2. We didn't actually need to write takes 1 right here. For these kinds of reverse crisscross where we have the formula and we're trying to find the name, for this case is pink nickel fluoride right here. Set up by writing out this formula and then doing a reverse crisscross, meaning that you go up over here and we say overall giving 2 and overall takes 2. Okay? If you have this strange situation, well, let's see here. Oh, this might not be. No, I'm going to have to think about this again. This is the great thing about teaching is that you constantly figure out that you were thinking about this in a slightly different way. Okay, so how are we going to fix this? In this case, we have giving 2, overall giving 2. And let's see. So we should, by that thinking and by this thinking over here, we should have written nickel 2 fluoride, right? I think what I might have been kind of messing with me before, this is not the right way of thinking about this, because this, I see what the error is. Normally this would always be reduced. Aha, that's what it is. That's what's confusing this. Okay, so let's rewrite this whole thing, because normally you would never be given 2 and 2 as little subscripts right here. Like the Ni2, F2, you wouldn't be given that. You'd just be given NiF because it reduces. So if you've got Ni and you've got F, that means with the little ones down here that are invisible, you would reverse crisscross those. And that means it would be giving 1, gives 1, and this would be taking 1, takes 1. Yeah, that makes more sense. Okay, so that means that the nickel would give 1, and this fluorine would take 1, and we don't ever really care about this in our formula writing over, or in our name writing over here. We just care about this because this is the weird one where we don't know how many electrons it's going to be given just by its name. So this would be giving 1, and that's what we wrote down over here. So this jives perfectly with this last example over here, where niobium and oxygen have Mb2 and O3. If you reverse crisscross this, it's going to work out great because oxygen is taking 2, and this niobium atom is giving 3. And that's what we wrote over here for our names. So hopefully that made sense. Sorry about that little trick with the 2's right next to there. I shouldn't have done that. Bad, Mr. Sand. Hopefully that makes sense. I'll see you later. Bye.